Hi, Mrs. Brown here. I want to talk a little bit about problem solving. So this is a big part of this Unit 7. I know we already talked about memory and we started going into cognition a little bit. Later on, we're going to talk about language, but problem solving is huge for psychology because psychology is all about, how do we solve problems? So there's several different ways that we solve problems. We use heuristics, we use algorithms, and some other methods as well. So I want to go into some of this with you today. One way that we can solve problems is through trial and error. So we try things. If it works, great. If it doesn't work, we keep trying until we find a solution. Kind of the opposite of trial and error and the opposite of heuristics would be algorithms. So algorithms are for sure going to find the solution. It's just that they take a long time. So they're much more accurate. They're much less prone to bias or subjectivity or stereotyping or whatever, but it takes longer. So, it is a rule that guarantees the right solution to a problem. And usually we use a formula, we try every single combination of numbers, or we have like a program that runs an algorithm that tries every combination for us. Or we, painstakingly, step by step, logically go through all the possible solutions. So they work, they do. They'll give you a solution, but they're not always practical. In fact, they're pretty impractical because it takes longer. So if you see the word formula or calculated step by step or logical or more accurate, less prone to error, but takes longer, we're talking about an algorithm. These are just little cartoons. Okay, so if I had to guess a phone number using an algorithm, I would do every single combination. And so that you can see like how long this would take. This is only changing one of the numbers. So they're slow, they're very slow and not practical, but they're accurate. And so computers use algorithms to find solutions. The opposite of this is heuristics. So heuristics are using shortcuts, more prone to error, more likely to be biased or playing into our stereotypes, but when it's right, it takes a lot less time. So we say it's a rule of thumb strategy. If you see rule of thumb or a shortcut, you should think heuristic immediately. It allows us to make judgments and solve problems. It's a shortcut, but it can be prone to errors. So like, for example, and this plays into a lot of heuristics play into our stereotypes, into our prototypes. The best example that would come to mind of something. So if you're like, oh, which of these two people would you trust to babysit your kid? Using heuristics, you might have a stereotype that this guy up here, is like a grunge rocker dude. I don't know, but he might not be as reliable as this sweet old grandma, but you're using a heuristic to make that decision when in reality, the grandma might be senile and not really remember that your kid is there, and this guy might be totally responsible, like a straight A student and has taken babysitting classes or whatever. So if you answer based on your heuristic of their appearances, that can lead to some errors in judgment. Again, rule of thumb, you can solve a problem, it's a shortcut, it's quicker, but it's more prone to errors. Okay, so if I were to say, guess my phone number using a heuristic, all right, you might say, okay, well, I know you're from, I know you're from Northern Virginia, so you probably either have a 703 or a 571 area code, something like that. So then you're taking a shortcut, or DC 202. Now, this is great. This is right. But what if I had lived in Minnesota and I moved here from Minnesota and I didn't have that area code? Now you've made an error. So you see it's a shortcut, but it's more prone to error. unscramble the word using a heuristic instead of trying every single letter combination and changing just the U and the E and then changing the N and the U and then changing the U and the Q or whatever. You can use kind of some rules that you know to say, okay, I know that whenever we have a Q, U, E, you know, we're looking at this looks like the word unique. Because Q and U go together, we can take the shortcut of putting those together and then figure out the rest. Okay, so again, when you see formulated, calculated, step-by-step solution, you should think algorithm. When you see shortcut, rule of thumb, you know, prone to error but faster, you should think heuristic. Insight is another way that we sometimes solve problems because instantly, insight, the solution just comes to us. It's our aha moment where the light bulb, you know, in those commercials or those cartoons, and all of a sudden it's like, ding, oh, I got it. I got the solution, and just kind of comes to you. So this is what we mean by insight, a sudden and often novel realization of a solution to a problem. If you're like me, insight tends to happen at like 2 a.m. You wake up and you're like, I got it. But at that point, it's like 2 a.m. So what do you do with it? But it's that sudden realization. Here's a light bulb. Ding. There's no real strategy involved in insight. Sometimes it just takes longer for you to process and then it just comes to you. So there you go. All right, here's a practice question. Tyrone is trying to solve a complex anagram puzzle. He systematically, should be a key word, he systematically tries every potential solution by testing each possible combination of the letters provided. In this case, Tyrone is, what is he doing? He's not using a heuristic, that's for sure. He's using an algorithm, right? Systematically tries each possible combination. So the answer is A. He's using an algorithm, okay? What are some obstacles to problem solving? Like my hurdles. This is where we get into some of the obstacles that we bring onto ourselves, if you will. So one obstacle is confirmation bias. And this is the tendency that we look for information that confirms our preconceptions. Okay, so if I'm like, man, I swear every Tuesday it rains. Every time it's Tuesday, it is raining without a doubt. And every Tuesday that it is raining, I'm like, see, it's Tuesday, it's raining, I told you. But then the Tuesdays where it's not raining, I just kind of don't pay attention to that. Then all those Tuesdays where it is raining, I'm just confirming my preconceptions, right? Here's another example. If you believe that during a full moon, there's an increase in admissions to the emergency room where you work, you'll take notice of admissions during a full moon, but you're inattentive to the moon when admissions occur other nights of the month. So this does have to do kind of with selective attention and what you're choosing to pay attention to. You know, if you think that someone doesn't like you, you may start to, you know, every time they do something that you think is remotely showing that they don't like you, you start really paying attention to it. And you're like, see? And it's just confirming what you think. But then when they do nice things, you might just completely ignore it or not pay attention to it. And so that's playing into your confirmation bias. You're not seeing the full picture. You're not seeing, you know, all the other things that are going on too. And so we humans, we do this. We search for things to confirm what we believe so that we feel like we're right and justified. Here's a problem for you. Can you arrange these 6 matches into 4 equilateral triangles? So if you want to pause the video and think about this, you can. We're not going to take that much time. All right. But some of you said, no, absolutely not. I can't do it. It's impossible. There are 6 matches and 4 triangles. It's not going to work. Okay. And so if that was you, which I'm with you on that one, and you couldn't figure out this solution, you were suffering from fixation, the inability to see a problem from a new perspective. One example of fixation is called functional fixedness, where you can't take an object and use it in a new way to solve your problems, you always think if that's the object, it has to be used in that way. For example, if someone's coming at you and they're trying to attack you and kill you, hopefully you're never in this situation, and all you have is a hammer, and you were like, what can I do? I have nothing to defend myself. You're suffering from functional fixedness, because clearly you can't think to use that hammer to defend yourself, which you could, because in your mind, a hammer is used for hammering nails or as a tool or whatever. And so that's an example of fixation. Now, those of you that are big psychology buffs, I don't want you to get confused for fixation and problem solving, not being able to see a problem from a new perspective, being very convergent in your thinking and not being able to think divergently. I don't want you to confuse that type of fixation with, later on, we're going to talk about fixation that was talked about by Sigmund Freud and the stages of development, psychosexual development, and fixation within those stages that can cause some issues later on in life. So 2 different types of fixation. So I just want you, if you're looking ahead or if you're using this to review, keep in mind that these are 2 different things. Here's the 9-dot problem. Without lifting your pen from the page, can you connect all 9 dots with only 4 lines? You can pause this if you want. If you're in class, you can go back and do this later on. But we're not going to spend that much time. Okay, here's the solution. Whoa. There you go. Okay, if you were like, no, I can't do it, it's impossible, you're suffering from fixation. Open your mind. Think outside the box, right? Literally, think outside the box. There you go. All right, here's a practice question. A heuristic is a flash of insight? No. A guiding principle or rule of thumb used in problem solving? Ding! That's correct. A methodical procedure for trying all possible solutions is what? An algorithm. Good. Okay. A way of making a compensatory decision? No. All right. A mental set. All right, so this is your tendency to approach a problem in a particular way, especially if that's worked for you in the past. So this can be good to help you solve problems, but it also can be an obstacle to problem solving if you're like, man, I can't think of a solution because I always do it this way and it's not working. And so an example of this might be if you're like me and you learned a set of rules to do math problems and you always, you have a problem and you always do it a certain way, and that particular problem, you can't do it that way and it requires you thinking of a different way to do it, and you're like, well, I can't do it. So then your mental set is blocking you from being able to solve that problem. If you're like, I've always learned this way, like I've always done flashcards, and then your teacher says, well, you're going to do a fan fold for your vocabulary, or you're going to do, Quizlet or whatever, and you're like, but I've always done flashcards, and then, that's preventing you from being able to learn the vocabulary. That mental set is an obstacle to problem solving. So you have to think about that. So it may or may not be a good thing. Functional fixedness is an example of fixation, the tendency to think of things only in terms of their usual functions. Okay, so what are some things that you can do with a quarter other than spend it? I always use these for like scratch offs, because one day I'm going to win the lottery and supplement my teacher salary. Or, some people use quarters to play quarters, right? So if you are using a quarter for something other than as money, you do not have functional fixedness. You do not suffer from fixation. But if you're like, man, a quarter's a quarter, can't use it for anything else, then you are suffering from functional fixedness and fixation. Here are some examples. No functional fixedness here. Genius. He's used his Jack Daniels bottle for a mouthwash dispenser. He's used his, what is this, a GameCube, I think, as a tissue dispenser. This guy put socks on the toilet so he didn't have to sit on it, right? This guy's using his fan for his computer not to overheat. This guy's fashioned a wheelchair out of a lawn chair, whatever. Okay, yeah. All right, so which of the following is a good example of functional fixedness? Failing to use a dime as your screwdriver when you've lost your screwdriver. Yeah, okay. Not being able to solve a physics problem because you always apply the same rule, that's mental set. using a blanket as a pillow, that's not functional fixedness. And adding water to cake mix when it calls for milk, that's also not functional fixedness. So the answer is A. Stop this video here. Hopefully you enjoyed learning about how we solve problems. We're going to pick up in the next video with some more about problem solving strategies.